All right, welcome you all to today's class and good evening. The last time we are talking about internet protocol with regards to the internet layer, the protocols that work in the internet layer. We are talking about the IP version 4 and IP version 6. So we had a good one to stress on the point of why IP version 6 came on board, irrespective of IP version 4, and the problem it came to solve. We also were able to touch on network segmentation, which allows us to be able to have our networks subnetted into various networks so that we'll be able to help with traffic controls and not to be able to burden a certain network with so much traffic that there will be difficulties in communication. And then we also talked about it helps security efforts in the sense when we know that our networks are subnetted into various departments. In the case of things coming up, we will be able to avert the situation easily because we can be able to trace where the problem is coming from, unlike when everything is on a particular place. I guess that's what we did. And today we want to talk about protocol enablers to the internet layer. When we talk about protocol enablers to the internet layer, we are saying that these are protocols that are either above the layer of the internet layer or below the layer. But due to that, the thing that they do, the protocols that function in the internet layer needs them in order to fully or kind of need them assistively to carry out the function they are meant to carry out in the internet layer. So when we talk about enablers, we are talking about protocols that look like as if they function in the internet layer because the internet layer kind of, or what happens within the internet layer kind of requires their services. And at times we want to say that they belong to the internet layer, but they don't. So they are called enablers, somebody to assist you with something, and then you take it up from there. So whether they are above the layer or below the layer, you will get to find out because they are necessary for the internet layer to work. Sorry, for protocols to the internet layers to work with them. So that is why the topic protocol enablers to the internet layer. So are you all with me on that? If it's so, can I get a thumbs up? If not, can somebody raise up their hands and consign with regards to what I just said about protocol enablers to the internet layer? Okay, thank you very much. So let's proceed. One of those protocols is dynamic host configuration protocol. If you are if you have been following all through the course of this lecture, you will notice that there was some time I was telling someone about IP address and not entered like manually. There is a means through which IP address can be assigned to you automatically. The same way most of us are on the internet now, but we didn't configure any IP address on our devices. So now you will not be pointing out for me, since IP addresses work in the internet layer, that is IPv4 and IPv6, they are what they are the IP addresses we are talking about. They help the IPv4 and IPv6 help in assignment of these addresses to devices so they can be able to be recognized and located and communicate on the network. So you now see that dynamic host configuration protocol is a protocol that enables this assignment to happen. So when I say protocol enablers, I'm talking about things that support the effort of the protocols in the internet layer. And one of them is this dynamic host. So it's enabling to make those addressing possible. But they themselves are not the internet version 4, which is operating in the internet layer. So dynamic host configuration protocol is an application layer protocol. As I said, in the TCP IP, we have the network layer, we have the internet layer, we have the transport layer, and we have the application layer. So dynamic host configuration protocol is an application layer protocol that helps to take those addresses that should have been done by the means of IPv4 address assignment. It takes it and makes it automatic. So we don't have to stress ourselves to configure them statically. We use a dynamic host protocol to assign them to devices. This involves whenever you log into a network, you don't need to configure anything. You are not the one that types out your particular IP address, which has IP address, which is the one that identifies the particular host on the network, the subnet mask, which tells us where your network belongs to, and the default gateway, which tells us the router, that's the way to exist your network to through the internet or to another network. So the means by which you try to get resources from the internet or from any other network. That is what the default gateway is. The default gateway is usually the router's local IP address. That means the router that is connecting your network to other networks or to the internet. The IP address of that router is what we call the default gateway. So the IP address, subnet mask, default gateway, for these things to be assigned to you, the dynamic host configuration protocol does it automatically. So instead of you to configure the IP address, which belongs to the Internet Protocol version 4 or 6 under the internet layer, the dynamic host protocol relieves you the stress and does it on your own behalf, giving your devices ability to what? Communicate. So that's why I term these things I'm discussing as protocol enablers for the internet layer. Are you all with me on this? If so, can I get a thumbs up? If not, can I get someone raise their hand to express their concern? All right. Okay. So thank you very much. So we can move forward. So invariably, you can see an image trying to depict what I'm trying to say. For most of you who use a phone, you can see that you are using DSCP. DSCP is a protocol that has ensured that you get an address that enable you to connect to the internet. So most of us using mobile phone, there is this mask that we usually see within our environment. Is either it belongs to your ISP, which is mostly MTN, Airtel. For those in Nigeria, I don't know about those in other countries, the kind of service providers you have. But whatever it might be, I know there is always a mask around. So when you are as a mobile device person, you are not statically giving your device address. So it dynamically gets it from this mask because there is a DSCP server within the ISP infrastructure that gives you an IP address. So you can see it is assigned wirelessly to the person. It can be also, this thing can be wired in a setting. It can be wire or wireless uh, kind of transmission or configuration that happens. So we can see the mobile service divider gets their own mobile worker or somebody using a mobile device to get their own IP addressing directly, and they don't need to configure anything. So that's the function of what DSCP does. You can see in a corporate network, we are seeing the local DSCP server. It will provide all these devices with IP address. The network engineer don't have to go to one place to another to try to configure those IP addresses on those devices. This is a diagram that is depicting what I'm trying to say. So are you all with me? If that's so, then give me a thumbs up. If not, can I get somebody raise their hand to express their concern? All right, thank you very much. So I still have to reiterate or come back to the fact that there are two ways IP address can be done. That's the IPv4 or IPv6 address that can be assigned to a device. There are two ways, either static or dynamic. So it is because of this dynamic that we have the DSCP, which is a protocol functioning in the application layer. So statically, if you are doing it statically, that means you have to, every device that have to connect to a network, you'll be the one to give them IP address, give them default gateway address, assign them a subnet mask. So you are the one to be able to impute those things with them. And I guess that I was able to show you how to difference between static versus dynamic IP address assignment. Have I been able to show you that? I will show you that. Sorry. Sometimes I conflict with some other classes. So what I'm invariably saying now is that static, so dynamic IP address. Static, you have to get every devices and do it yourself. You have to enter them manually. But the only amazing thing about that thing that you are doing is that also when you are able to impute your address statically, it helps to ensure that you can be able to keep track of the devices that you are imputing. That means you have a record about the IP addressing that you have given out. And just in case, in terms of security, when some kind of IP address you didn't assign comes up, you can be able to say this, and this is the wrong person trying to connect to our network. So there was nothing like that. So you can be able to know because you have a proper account. That's just the only thing about it. And then devices that you want them to be static, like static, what I mean, devices you don't want their IP address to change, requires you to use a static IP addressing. But in dynamic, it's just that once a device offs their connectivity, if they connect again, they will get another IP address. So when you are looking forward to something like you want to connect your printer to a network, of course, you'll be thinking about using a static IP address because your printer is not meant to have a dynamic IP address. It has to have a static, so everybody, no matter whenever they connect to the network, they can be able to print. So what is dynamic simply means that it can change. So if they connect today, they will have another IP address. As I already told you that IP addresses change. It's only MAC address that don't change. So IP address, once they connect today, they will have a different IP address. If they connect tomorrow, they will have it. So far, they are not connected on a consistent basis. Maybe by mobile devices, laptop, you do shut them down. Whenever you shut them down, whenever you come up again, you receive a different IP address. So that's invariably what I'm trying to say. So when you are looking forward to using devices that are static, that doesn't change, use static IP addresses to configure them. Then when we are talking about devices that are mobility, that has mobility, that can be taken from one place to another, they connect to a network and they off and do this thing. They are not regularly on a network. Sometimes this person can come to work, sometimes they don't come to work. So those kind of devices, or maybe you are running a kind of restaurant and then your customers come, they leave. So of course, dynamic IP addresses will be better for them because you can't tell them every time, bring your device, let me put in so that I can be able to. So there is times when dynamic are effective and there are times where static are effective, as I already said. So it's just that the thing that dynamic brings it releases of the stress of configuring from one device to the other. Then that's about the static and dynamic IP address assignment. So are you all with me on this? If that's a yes, can I get a thumbs up? If that's a no, can somebody raise up their hands to express what they want to talk about? All right, thank you very much, Honor. So let's move forward. So this is an example of what I'm trying to show you. If you can look clearly to the image on my screen, you will see that use the following IP address is a manual form of configuration. That means you have to enter the IP address, enter the subnet mask, enter the default gateway, then enter the DNS server. As I already said, DNS server simply means a server that provides us with information. So whether email information, whether web information, whether anything that is information, that's what we call a server, a domain name system. So it provides us access to countless websites. We can access them with domain names, and then the IP address conversion is being done by this domain name server. So the IP address, as I already said, is used to identify every devices on the network. So that website you are browsing is has an IP address. So the only thing that it was done that it was converted to something we can understand. So whenever you input in www.com, google.com, just know that it has an IP address. And I am going to prove all these things now. Both they show you this and then um, show you the dynamics. So how to go about configuring a device either manually, but once it's dynamically to receive the IP address by itself. Are you with me on this? If so, can I get a thumbs up? Then I'll move forward to show you this image that you are seeing, how it's applicable, how the domain name system works. All right, thank you very much. So permit me to uh, reshare my screen to present something else. All right, I'll be sharing my entire screen so as to make you understand what I'm saying. So look at, sorry, I want to be using, I hope you can see this. You can see this, right? You can see my command prompt. You can see, can I get a thumbs up? Can you see this power command prompt? I'm moving from one place to another. All right, so I want to get the uh, DNS of www.google.com. So I want to get it. You will see it will translate back to an IP address, and we'll use that IP address to search for what we want. So everything that you want, you are typing as alphabets are they are, so far as they are connected to a network, they have an IP address. That's just what I want to try to prove to you. That what DNS does for us is to help to convert those names that we type back to the original IP addresses that those systems would have. So DNS of www, sorry, um, what's it called? What is it called? Sorry, oh, I've yeah, I've forgotten. Sorry, DNS of okay, I've gotten what I needed to DNS lookup. So DNS lookup www.google.com. So you want to know the IP address that is associated with this. Why is this thing doing this? It's not recognized as internal operable command DNS lookup. Don't worry. I don't know. Have I forgotten this command?
Hey, Mr.
Sorry.
Michael,
Yeah.
sorry. How about if you use ping? Is it different
Guys, right.
than ping and DNS?
Okay, sorry. Yeah, just ping is just to be able to for connectivity or accessibility. I want to remember this command. Okay, NAS lookup. That is the command. Sorry, www.google.com. I just want to know the IP address that www.google.com translates to. So as you can see, this is the address. Are you seeing the thing I'm trying to show? 192.168.47.104. So this is the address. So when you type in that www.google.com, this is what the DNS server helps you to do. It brings it back to this address because every system on the internet or a network have an IPv4 or IPv6 address. So it's not that name. So what DNS server, while you are imputing it when you are configuring, is to be able for it to do the translation. So if you are still in doubt, I will copy this IP address and then we'll use it. I will copy this IP address. I will copy this IP address and we'll use it to we'll use it to access we'll use it to access the web browser. Jacqueline, can you please off your mic, please?
Nenda nikupe ingine yako, nikuletee yako ya kala.
All right, so sorry about that. So invariably speaking, what we'll now do, I've copied that address, so I can now be able to do what? Enter it here and see whether we'll access Google website. The all right. I don't know what's happening to my network. I don't know what's happening to my network, but let me check for DNS Cisco.com. Sorry, NAS lookup. There's NAS lookup. Cisco or Cisco.com. All right, so let's try this. I don't know whether. All right, did I copy that then? Well, okay. This is Cisco.com. All right. I don't know. All right. This is it. So we were able to use that, what's it called? We were able to use that IP address to get into this website that we normally type cisco.com. So I know why we are having issues at first was there is a this thing firewall blocking out using of IP address on this. So that thing that I said that time we are doing practical, trying to show you how to. So there are things that it will not allow you to do, especially when IP addressing is trying to be used on the web instead of the normal DNS. But meanwhile, we still were able to get through. So this address here, 72.168.4.185, will translate to cisco.com. So invariably, that's what DNS does for us, and that's how pretty good it is. So furthermore, there is also something I wanted to show you. I said I wanted to show you how to configure. So I will do uh, internet network for internet. I want to show you how you're able to get those image. So as you can see, this is my Wi-Fi. I will right click properties. So you are seeing Internet Protocol version 4, TCP IPv4. I'll double click on it. So it said obtain an IP address automatically, which I am using. But if I don't want this, I want to configure, I will just simply go use my own IP address. I will start configuring 192.16.10.1. But this is majorly what you see people in network engineering doing. Sorry, I said network engineer, they are network person. So I'll start configuring the gateway 192.16.10.1. This should not be this stage of this one. Okay, so I'll configure a DNS, that one that enables us to. Google has a public DNS 888. So I'll configure it, but I will not click OK. If I do it, my network will be disconnected. So I will only configure this when I'm sure about a network that I am connected to. So for now, there is no network like this I am configuring. I just wanted to show you how the image came about of trying to configure uh, your IP addresses statically and then dynamically. Dynamically, what brought about it was the the DSCP, which is a protocol enabler for IP addresses. So it helps to be able to assign devices. So I hope you all follow through on the little thing I wanted to show you on. If that's so, can I get a thumbs up? If not, can I get you to express your concern? Oh, Stephanie, you can go ahead.
Please, I'd like to ask, what's the command prompt to convert your IP address to back to DNS server? Like
Command prompt to convert.
the command to convert your IP address back to DNS server.
All right, it's still the same thing. You just have to do NAS lookup. That's name system lookup. What was that? 72.163, I think that's it, .4.185. Though it's saying unknown server, but look at the name. Redirect nas.cisco.com. So it's telling us the name. So if you are not sure of any IP address, and then you can type out NAS lookup. If you look up the IP address, is there anyone we need to also look up for NAS lookup for 192.168.47.104? Okay, it couldn't find this one. Let's do NAS lookup for google.com. So let's now do NAS lookup for the address 216.58.223.238. So most times you want to see google.com, but maybe Google has so many servers that is redirecting to. So invariably, this is their name. but they have so many servers you have to go to. So sometimes, most times, this is how it works. If you use NAS lookup, it's actually to find the IP address of a particular domain name. That is what is usually used for. So at times, trying to use the NAS lookup for the IP address in order to know the domain name, invariably, most times, you will see something of this nature that is not probably would result or resemble that IP address due to their what we call the directions in trying to find a particular result. That means whereby a resource you want to find for it, another service or another server needs to provide you with that information. So in that case, what you'll be seeing is the server that is acting as the middleman between you that is requesting and the main server that is providing it. I think I have said something on that before. No, I guess so. I've not said it. It's still one of the things we will do. Have we done something on Prosy? Have we done something on Prosy servers here? I think we have.
Not yet.
Have you? Eh?
No,
No,
sir.
You have not
not.
done. All right, okay. I thought I explained something on Prosy server before, but yeah, we have not gotten there. Yeah, I think that's one of the things. So Prosy server, since I've studied, let me say what it is. It's like a people does feel like somebody contacting my device directly is risky. So they will place a device in the middle, acting as the middleman. So when you contact, you don't contact the main server providing, you contact the Prosy server. So that Prosy server will not send your request on behalf to the main server. So you don't know the main server that is producing that information. So you are just meeting with the middleman. The same way most of you are buying things from the middleman. But most of you go to market. When you go to market, you meet somebody, right? Most of you in Nigeria, I don't know for other countries. And that person doesn't even own a shop. But the person will be like, what do you want to buy? I have it. You tell the person, you say, I have it. And then you take you to the person's shop and do what? And pick everything and give it back to you. You don't even know the shop owner. The person is the one already the service, but he's not even a shop owner. He's just a middleman. So that's what Prosy servers do. They stand as the middle between you and the main server. So they kind of make it unable for you to know who is actually providing the information. Are you all with me on that? Somebody is raising up their hands. You can throw up your question.
Good evening. Please.
Good evening.
Okay. And I just want to raise concerning the ping that I said. But when I use
Okay.
ping for google.com, I got 216 dot. Let me see the address again. 216.58.223.196. And when I tried to copy it in my browser, it brought it as google.com.
Yes, now it will bring it back to Google. It's your browser doing the redirect. It will bring it back. But when you copied it and pasted it, it will bring you. That's just to show you that domain name server, that is how they work. It changes IP addresses to domain name and domain name to IP address. So that's their duty. So you, as a person interfacing with it, it will show you domain name. But the engines that are running at the back, it will be showing them IP address. That's just one thing about it. So it makes the machine, it communicates to the machine with IP address, but it communicates to you based on what you understand, which is what? Which is domain name. Is that clear, Rafiat?
Okay. Yes.
So somebody like Felicia was raising up her hand before. I don't know. Victoria, you can go on.
Okay,
You can
good
go on,
evening, sir.
Victoria. Good evening.
Yeah, good evening, sir. So you were
Yeah.
explaining the proxy, and I was asking if it's similar to VPN because they sound alike.
Not really. What VPN does for you is to masquerade, to encrypt your location and your IP address. That's what they do, right? They are not actually doing serving any service for you. Like they are not, there is nothing like a physical thing. They are just a pathway through which information is passing through. So it's kind of the same way, what is it called? Uh, if you have been in a traffic before, all these government officials are trying to move in between. There is a special way that is made available for them to pass through. So you don't hold them up in traffic. All these special vehicles that either they are carrying a dead body or is government official. So you don't hold them on the traffic. They will make path for them to pass. That's what VPN does for you. It creates a particular tunnel beyond the crowd. What is it called? Between the public thing, so that you have free will. Nobody will be able to see your message. Nobody will be able to. So it does what it does. But what Prosis does for you majorly is to act on behalf of someone. So VPN is not acting on your behalf, it's just shielding you from something. So it's not acting on your behalf, it's just protecting you from something. So protecting and somebody is serving. So that one doesn't protect you, though it's a way of protecting. But somebody can still be able to discover that there is somebody standing in between. So if you tell me something, I'll go and tell somebody else. That's what Prosis are doing. But in VPN, that's not what it's actually doing. VPN actually just creates a tunnel for your communication to flow without anybody having a way to pierce through it to know what is in it. I don't know if that's clear.
Yes, thank you, sir.
All right. So is there any other person? Felicia, are you still on the call? I was seeing you trying to. Are you okay? Is everything fine? Felicia. All right, Bala, you can go ahead.
Okay, thank you, sir. Good evening, sir.
Good evening.
Sorry, please, I joined a bit late. I wanted to just understand like what today's class is about. Is it like the practical aspect of the class or something?
No,
Because just a lot of things here.
today's class is just protocol enablers, more of protocol that enables the IP protocol, which functions at the internet layer, to work better. So something like IP addresses are given because we have IPv4 and IPv6. So some protocol like dynamic host configuration protocol helps us to assign IP addresses to devices automatically. So that was what brought about trying to show us how dynamic configuration works and how manual configuration works. So when dynamic configuration protocol came to be, so it relieved people the stress of configuring devices manually. So they cannot be able to assign or get IP addresses. The same way most of us, we don't configure IP addresses on our device. We get them automatically by our service provider. So that's on that. All right, Felicia, you are giving me a down thumbs up. That was what I was trying to know if anything, everything was in order. I saw a down thumbs up. A down thumbs up simply means I have concern. So that was why I called out to you. Ayomide, you can speak.
Good evening, sir.
Good evening.
My network locked me out at the point where I'm so sorry. I feel so lost in today's class. I stopped where I don't know, there was a black screen, something like a command, something like that. I'm really, really lost. Please, sir, find me.
So there was nothing much. I've not even done anything much. I was just trying to say protocol enablers, dynamic host configuration protocol. It helps us in that IPv4 addresses that we need to get in order to communicate on the network. DSCP helps us to do the assignment of those things automatically. We don't need a network engineer don't need to go to one device after the other to configure it. So that was invariably what I was saying. That was a diagram to depict what information I was trying to pass across on how this works. You as a mobile user, you get your IP address without configuring it on your device. How is that possible? It's because of the dynamic host configuration protocol, which is an application layer protocol. That means it's functional at the application, but it enables the internet layer, because in the internet layer, that's where we see IP addresses. So because it enables it, we can't say it's under the internet layer. It's still an application layer, but it has a work to do in order to help devices to get IP addresses. So that's what I was invariably saying. Then I was trying to now say in IP address assignment, I was trying to differentiate between static and dynamic, because dynamic is the one that helps us to assign automatically without our involvement. But static is what helps us to do it ourselves manually. So if we want to make devices communicate, we have to statically configure it. So what dynamic came to help for us, come to do for us, is to make it easier. Where we have large network, why is not even able for us to do it? Just imagine 500 devices, configuring and going through them one after the other. So what dynamic is doing is helping us to work out what the work of IP addressing should have done. Why we should do it on a manual. Dynamic takes up the stress. So that was what I was explaining on the difference between static and dynamic. Then I went to show us how to do it on a system. That is where this image was coming from, trying to tell us how to do the configuration on a system. I don't know if that's all for Bola and for the person that said that she is lost.
Thank you, sir.
Is that clear?
Well, it is not so clear, but I feel like as the class goes on, I would understand. But thank you very much, sir.
All right, Bola, what's the issue? Are you cleared, Bola?
So my hands are not raised up again. No.
I mean, what you said I should explain for you that you are lost, you logged out, you logged in. That was what I said. Are you clear on where we are now? We have not even done anything, sir. I was just trying to go around and show them something pertaining to this image. Huh?
Okay. Yes. I will just follow the class. I get what you're saying. Thank you, sir.
Okay, somebody said, are you able to explain steps in DSCP address assignment? What happens until a device is assigned an IP address via DSCP kindly? Okay, what really happens is this. When you on your IP address, when you on your trying to connect to the internet, once you have seen a network connection showing up, maybe a hotspot, you click on it. Once you click on it, what your device does is to send a DSCP request. Give me an IP address from the DSCP server. That's what it does. So it's kind of asking, please, I need an IP address. I need an IP address. DSCP Discover, that's actually the name. DSCP Discover. It searches for it, it's seeing it. So when it sees it, okay, when you on your hotspot, let me explain this better. When you on your Wi-Fi, is it Wi-Fi? Yes, hotspot is the one someone owns for you, then you on your Wi-Fi. So once you start discovering networks that are available. That is the stage of network discovery. Your device is probing to see a network. All right. Once it clicks on it, it has discovered the network and it has clicked on it. So the device will send you a IP address. That's the DSCP will send you an IP address. Once they send you an IP address, your device would accept or look at the IP address and say, okay, I want to use this IP address. It will send back information. I want to use this IP address that you provided me with. Then that device that is providing it will send back and say, I now acknowledge that I have given you this IP address. I can't give it to any other person because you are not the one using it. So the way it happens is DSCP discover a dynamic host configuration protocol. Then that one sends you a kind of supplies you with the IP address. You now kind of I want to request this. I need the IP. I'm accepting the IP address you are giving me. The device sends back to you and say, I acknowledge you are the one that's what needs this IP address or have taken this IP address. So that's the step it was. Exactly, that's the step it was. So if not, I'm willing to go back and repeat anything. That's not a stress at all. So that's you have to understand. You have to follow through. That's okay with me. So can I move forward? I'm not everywhere is just dull today. Is it that we should start afresh? All right. Should we start afresh? There is nothing I'm even still in slide 5. The slide 1 is the title. The slide
Yes.
2 is just the dynamic, one of the protocol enablers. Uh, Ayomide, what did you say?
If possible,
You said
sir.
we should move forward
Please,
or
sir.
start afresh.
No, you said can we start afresh? And I said if possible, please, sir.
All right. So what I was saying is protocol enablers the internet layer. I was kind of telling you that enabler simply means what is supporting the effort of the protocol that operates in the internet layer. That doesn't mean that this protocol belongs to the internet layer. They might belong to the layers above or to the layers below. And as I already told you, the TCP/IP model has four layers, which are one network layer, internet layer, transport layer, and application layer. So when we say protocol enablers, those protocols that are in any of these layers, but they are supporting the efforts of the layers of the protocol that are in the internet layer. So when we say protocol enablers, note these are protocols that are not in the internet layer, but are supporting the efforts of the protocols that are working in the internet layer. And one of the protocols or two of the protocols that normally we are conversant with is the IPv4 and IPv6 that works in the internet layer. And then when we started this discourse, I now made mention of one of those protocols, which is dynamic host configuration protocol. We know in the internet layer, there is the internet protocol, which is IPv4 or IPv6 that works in the internet layer. So what this dynamic host configuration protocol helps us to do is, instead of us trying to configure IP address, since every device uses an IP address, what this dynamic host configuration protocol is to automatically assign these addresses to this device. So in the sense that every device needs an IP address based on the internet IPv4 protocol that works in the internet layer. The dynamic host configuration protocol is a protocol that works in the application layer, but it helps us to take these addresses that are needed because of connection or connectivity on the network and assign it to devices. We don't need to configure it anywhere longer. And what are those things that it does? What are those things that it is able to automatically configure on the device? Is the IP address, which is the one that identifies uniquely every device is connected on the internet, the subnet mask, which is the network that device belongs to, and the default gateway, which is the router's IP address for every device to be able to request something outside of its network. It needs a gateway. That's a gateway is something that they have to pass through to either get information from another network or from an internet. And as I already said, the router connects different networks together. So these three things are the minimum things that the dynamic host configuration protocol would automatically do for a device that is connected on a network. So once you are connected, so far as you enable the dynamic host configuration protocol, it will assign you an IP address, and these are the IP address things that you will get. So I'm invariably using this diagram to showcase. I was using this diagram to actually showcase an instance whereby you receive dynamic host configuration, but you are not aware. When you are using a mobile phone, are you the one that configured the IP address? No, you are not the one configuring it. That is invariably saying that you are getting a configuration done automatically on your device just because you are able to connect to a network. So that means underneath or under hood is DHCP servers providing you with IP configuration, either by your ISP as the instance shows here. You can see this mask is a popular mask that we mostly see in our environment when our service provider mounts them. So we connect, then this mask speaks to a DHCP server somewhere in your ISP environment or their location. So it sends you an IP address. This was a diagram that I was using to depict an instance of how this DHCP works. And then furthermore, I was trying to now tell us the difference between configuring a device statically and using dynamic host configuration. That's dynamic IP address assignment on a device. So I was saying that static often goes with devices that do not change in a network. So you use it for devices that rarely change. That means they don't go off or they have to have a constant IP address because devices will always be contacting them. Something like your printer IP address shouldn't be changing. It has to be configured statically because it has to be known by everybody on your network, because everyone sends a particular printing order to it. So you don't have to give it a dynamic dynamic. So anytime it comes on the network, it will receive another form of IP address. So, but when we talk about dynamic, we are saying that any form of devices that come on the network at any point in time, something like your mobile devices, your laptop, you might carry it and go back home and come with it to work. And when you need to connect to the hotspot, so those ones can receive dynamic IP addresses because they are on mobile, they go. So we don't need to pass through the stress of giving them or configuring statically IP addresses on them. That means every day you come to office, you have to configure an IP address to use on a consistent basis. So those devices that are not often used or utilized, that come and go, they need to have a dynamic. We don't need to keep track of them. But devices that matter to us, something like our web servers, our printers, some kind of devices that consistently provide information to us, they have to have a static. We have to configure them. We have to take the stress. If it's the major devices that are essential for us, should have static IP address for security concerns and for security reasons. Why dynamic should just go for any device that just connects to the network, do whatever they want to do, and can be able to switch off or go back or use some other things or carried home. So those devices could have dynamic. So for a person configuring, you utilize dynamic when they don't want to pass through the stress. It's too much device to configure. So they can choose to maintain static where only essential devices are consigned, as I already mentioned. So that was what I invariably said. Before I now brought out this image to show us what it means to kind of choose to configure statically and choosing to configure. So these options, when we are in our devices like laptop, these options, we can be able to choose them and then go with them. So if you want to do it statically, you can do it. And I showcased it when I was doing this. And then if you want to do it up 10, which most of us normally use, is through this way. So we select any of the options. So any of the options you want to do it, you will use the following address. You are the one to configure it. If you want to get it automatically, so you don't have to pass through the stress of configuring every device, you just have to say obtain, and that device obtains IP address automatically. Are we on the same page? All right. So I can move forward, right? Are we all on the same page? Everyone that Bola and the rest that came late is dragging us. But it's important that you understand you are not dragging us, it's essential. So can we move on now? Thank you very much. Okay, so all right, so I needed to talk about network gateways and boundaries. Why do I have to talk about it? Because I mentioned something like what? I mentioned something like default gateway. I need to explain more about this default gateway. So what it means that every device that is connected in a local context, for them to have access to other networks or other resources in another network, there is what we call a default gateway, simply meaning the exit point of trying to get or request information. So exit point or entry point. So routers make it possible for us to connect to one or more networks. So for us to be able to go to the internet, we must have something beyond normal devices connecting in a local network. We can have something beyond the switch connection that is used in the access layer. We have to go over to the router that is used in the internet layer. So with that router, it kind of creates a gateway and boundaries. So the router has a facing point whereby only what happens on your network remains on your network. And if you want to go beyond it, you have to be able to have a default gateway. That is the router's IP address to be able to move from or send information across to any other network. So that is invariably trying to tell you that routers serve as gateways and also boundaries. When we say gateways, we mean a means through which information leaves your local network and a means through which information enter into. So it's a gate. So for something to leave, you must open that gate. And for something to enter, you must still open that gate. So router serves as the gate through which information can leave or information can enter into your network. Then boundaries, when we say boundaries, it also determines when information stays within a network and when information is permitted to leave a network. That's just simply what I'm saying. So when we say that default gateway, just simply know it is the router IP address that is connecting your network. so that whenever your network wants to access some other network, or when they want to access the internet, which is the network we are still talking about, they have to flow through the router, go through the router. The router gets information and sends back to them. Is that well understood? If it's so, can I get a thumbs up? If not, can I get somebody raise up their hand to express their concern? All right, Rofias, you can go.
Please, can you explain what boundary is again? I don't really get it.
All right. Okay, so just permit me to go back to an image to use it to explain this. All right. You can see that image, right? So if you can see this image, boundary simply means, look at a router here. This one, this is a router. Yeah? This is a router. So everything that happens in this circle stays in this circle. Every communication happening between these systems in this corporate network stays here until what? Until one system say, oh, I need something from this mobile worker. So once they say they need something, so the boundary of this communication, what the boundary is, the router is specifying the boundary. But once it is outside of this network, that means the communication that is meant to what exceed here is leaving, and that's what it has what taking the gateway. So it's going to here and then going to here. So, but if the information is ought to between these devices, they are sending communication within here. This router will not forward any communication outside. That is to say that it keeps boundary once information pertaining to a particular communication is happening within the local context. So outside of it, it has to forward back that word information. And the same also goes here. The information here remains here unless there is a move throughout the gateway for us to get some certain kind of information. So saying that routers act as a boundary simply means it gives information that is on a local to remain local, and it gives information that is going to be going to be that's outside of the network to also be able to go back and come back. So it doesn't take any information that is only required there and start forwarding it outside. No. So it has a boundary, it keeps a boundary of information that are local to remain in the local region. Is that well explained?
Yes, thank you. Hello, yes, I said yes, thank you. Can you hear me? I said yes, thank you.
You know, on your mic. All right, okay. So that was what I was saying with regards to boundaries. Okay, better still. This is also a diagram. I mean I knew the diagram was. So this is also a diagram. As you can see, this router is serving as a default gateway. So for this PC to get any information outside, it has to send it through this router. That's the default gateway. This router passes it on to the internet. Then the boundary, you are looking at the boundary it is maintaining. Look at the boundary. So anything that is just happening here, if it's just a communication between the DSCP client and this router, it will remain here. So it will not cross beyond here. Then unless it is on a basis whereby this client needs something above the local network can provide, it will take it. Even though when it is taking it, as that information is returning, right, it is also sent directly to this device, and every communication here remains here. So every communication above here also goes over here. That is invariably saying that local context communication will remain local, and internet level communication will still remain what here. So if this person requires something here, the router serves as the what point of what contact to be able to do what to do the bidding for them, and then on behalf of them send back the what communication. So this one here doesn't just all of a sudden have access to the internet. No. So the router keeps the boundary of the other network, and keep the boundary within the other network. So serving as the point of contact between the two networks. So does this diagram explain this better? If so, can we get a thumbs up? If not, can somebody raise up their hands and express their concern? All right, thank you. Okay, so another such protocol, we are done with the dynamic host protocol. Another such protocol that is enabler is the ARP, Address Resolution Protocol. So ARP is not an internet layer protocol. ARP is a network layer protocol. DHCP, as I explained, was a application layer, but it helps the efforts of the internet layer. So many people want to put it under the internet layer. No, it's not the internet layer. As I already told you all, when I was doing some kind of intro, I was more of telling you that for you to be able to send an information across to any device, you must know two things. You must know their IP address and you must know their MAC address. So you must know their IP address and you must know their MAC address. The same way I was trying to also tell you that IP address and MAC address can simply be referred to somebody's name and somebody's physical address. So if you know somebody's name and you're writing them a letter, it won't get to them because you don't know their physical address. But if you know their physical address and you don't know their name, it still won't get to them because any person can pick it up that is located in that address. So you must know the two things. You must address the person by their name and by their address. So that means it will get to the exact person that you want it to get to. So what address resolution protocol does for us is that at times, many devices know the IP address and they don't know the MAC address because MAC address is functioning at the network layer, as I already said. It is within the local context. So what they will do is there is a protocol that is called address resolution protocol. It will help them to discover the MAC address of the device that they have already known their IP address. So internet layer protocol functioning, they will already oftentimes know the IP address. So the problem is getting the MAC address of that device so as to properly send them the exact messages that belongs to them. So what they will do is to send a broadcast. I've told you what broadcast is. It's a kind of message addressed to all persons connected on a particular network. So when they send a broadcast, they will be like, broadcast, please, who has this IP address? Who has this IP address? Please, can I have your MAC address? That is what this address resolution protocol is all about. It kind of helps us to discover the MAC address of a PC or the IP address of a particular device that is assigned to a particular. So once it said, who has this IP address? Please, can you give me your MAC address? That particular device that has the IP address will reply with their MAC address. And now they cannot properly send that device a message, a one-to-one message. They don't need to broadcast again. So why they broadcasted is to know who have this IP address. All right, the same way most of us would do. Are you with me? The same way most of us will do. Oftentimes, there are many people in a crowd, and you are trying to find a particular person. You already know the person's name or something like that. You shout out Chinaza, and everybody turns out. Right? Everybody now turns out. Everybody that answered Chinaza turns. And you now be like, okay. Or somebody that answers Chinaza will turn. Or their full name, you call it out, they will turn. And you know that it's this person. You have something to tell that person. But you can't start telling the person that without identifying the person. That's also what address resolution protocol does. I know what the person I want to reach out to, but I don't fully can't identify it due to there are so many people on this system. So who has this IP address? Tell me the person. Who are you? Who is Chinaza on this call? Can you send me your MAC address? So once they send you that, you cannot be able to address communication to them. So when you shout out, Chinaza answers you, then you cannot call Chinaza come, and you now start telling them what they want to tell. So in the terms of where there is a whole lot of things, you just want to identify who have this IP address so you can communicate to them. That is invariably what I'm saying when address resolution protocol helps us to do. Is that what is well understood? So, but in IPv6, it is called neighbor discovery. It's not called app. When we come to IPv6, it's called neighbor discovery. But when it is IPv4, we call it ARP, and it is a protocol enabler that helps us to discover things. So in the sense that it works with the IP address to discover the MAC address of a particular device. So when I say protocol enabler, just know they help or assist the effort of the things that happen in the internet layer. Are you all with me on that? Do I have to explain this key process? Of course, I've already used these stances to explain it. Somebody is shouting something, the other person replies it, then the other person sends the person the information. That's what the key processes are. Oftentimes, I'm not this English here. Sometimes will be confusing, so that's why I have to be using these instances. So, can we move forward? If that's so, can I get a thumbs up? I think. So this is a kind of illustration to what I'm trying to explain. So as you can see, there is a device here, PC2, but this PC1 wants to send something to PC2. That's what it is. So PC1 wants to send something to PC2. PC1 knows the IP address of PC2, but doesn't know the MAC address. So it will shout, hey, who has this IP address? And PC2, it doesn't know even though it's PC2 that have it. PC2 now will now send them. Then you can now see that it will now use it to formulate the message it wants to send, because you can't send the message to anyone without knowing both their IP address and their MAC address. So you can see that PC1, the destination is this, the destination IPv4 is this. So it will now use it to construct their message. So without it, without the address resolution protocol, it can't be able to construct this. There is no way it can figure out the MAC address. So it is both with the name and the physical address, it will address it, which is invariably the IP address and the MAC address. Are you all with me on this? If that's so, that's also the same thing with this image that I'm trying to. All right. All right, so let's talk about the routing concept and process. As you said, we are still just trying to try most of the thing that is happening in the internet layer. So what's the routing process? Routing, since it's from the concept of router, what router does is what routing is. So what router helps us to do is to be able to do what? Is to be able to send messages across from one network to the another. So the routing concept was initiated because router was a major device in the routing process. When we say routing, we say the ability of something to go from one point to the other. So that path it takes, that process it takes for some message to go from one particular network or multiple networks to a particular device is termed as what? Routing. So how does this devices be able to keep track of these messages and forward it to the exact place? So invariably, let me just say something, or let me give you a scenario. So this PC1 here, for him to send something to PC2 here. So the routing concept says this: for this information to move from here, there are two routers. So the routing process says it has to go from this network, this router one that is connected to different networks, and then go to this one before it gets to this network, and the switch now sends it to actual device. So the routing concept has to follow the best path to reach it. I want to still go back to an image and show us something more aside from this. All right, where is that? Ahem. So if you are on this device, I'm just trying to use this to show you what I'm saying. So if you're on this device, you are the mobile worker. This is you. You are trying to reach a particular device. This is this device. Sorry, I know I lost you for a while. So the routing concept, as I was saying, is more of the abilities of this interconnected router to know the best paths to locate the particular device you are trying to send information to, so that we don't start going. Sorry, I lost you. Oh, sorry, I don't know. They said I disconnected due to server error. I don't know. So let me still share my screen and explain what I'm saying. All right, so thank you very much for your patience. So what I am invariably saying, so how would we be able to send information quickly and then it reaches the intended person? How do we know that this information would not take time and it will get to the, it won't be missed out in any way? So it is the routing concept. The routing makes it ability for information to pass from one router to the another, or the best pathways through which information will get to the intended person. So I think that this diagram is a clear way to explain to you how routing works. So this mobile person is trying to get this device that is here, this one here. So once it connects and sends information, this ISP wanders router receives it, forwards it to this. This ISP too will not forward it down here, because by virtue of keeping note of information around it, it has information that is around it. It knows that the best path to follow is not this, because it will hang and it will not get to the person. So what it will do, it will send this information here. This one will send it here, and this one will get it. So it doesn't need to go and start going hands and forth. So the routing concept is just a way of information transversing from one place point to another till it gets to the intended person. So the knowledge behind that information going from one place to another is reserved in the router that are making this information transverse through the network. So these routers keep what we call the routing table. So routing table is more of a memory that keeps track of every device connected to it. So it will take track of every device that is connected to it. So the routing concept and the process involved is because there is a router, which is a device that makes this routing process possible. And it makes it possible because it keeps track of information. It contains information pertaining to every network that is connected to it. So with the device called a router, keeping information with the routing table, routing concept or process is established. That means devices can be able to reach each other, no matter wherever location, even if it means that they have to traverse through 127 router, they will get to their actual location. Is that well understood? If so, can I get a thumbs up? If not, can somebody raise up their hands to express their concern? All right. So I think this is a better narrative. Also to explain more. So you see, getting that. So this goes and then gets this device gets it. So this router is just kind of getting this. So it doesn't, when I'm trying forward information, yeah, it goes here because it's the default gateway. Then from the default gateway, it gets to any person that wants to. So there can be many routers here. it will have to take the best part. It has to take, because it has knowledge of every device. So it has knowledge of every network. Remember what I was telling you guys on network address. If a router keeps track of network address, so when you even want to send a particular device something, with the network address, it can be able to decode which host that belongs. A minute, please. All right. Are you all with me? So what I'm invariably saying is that more of, apart from the way you just saw few devices connected here, there can be more routers, and the routing concept is still applicable here. So it will still, even if it's more than just the way I was showing you many routers there, it can still be able to connect and then receive the appropriate information for the device you are trying to send them to. So, all right, I think there is create a LAN and configure a DSCP, set up a LAN and configure a DSCP server for a dynamic host IP configuration protocol. So, yeah, for most of you who, I don't know, how many of you were able to do the packet tracer activity that I sent in? Was there anybody that was able to do it? The one I was trying to do that day, I was trying to show you all. Oh, Victoria, you did it. All right, for those who are willing to do, I've already shown you guys from my system how to be able to do the configuration packet tracer. It is user friendly. That means I'm saying that it is instruction based, so you will do it on your own. That's for those that want to be able to see simulation how the actual thing works. You can be able to do it on your own. So just to be able to connect those networks, then select DSCP, and then the device starts receiving IP address. That's just what it's all about. That thing that I showed you on here, or here when I was trying to show you how to Hello? I heard that somebody said they are lost. Sorry. I got kicked off from the network. I heard somebody say they are lost. Where were you lost from?
When you explain yes
Is that?
or the
Is that?
exercise.
Is that what?
Yeah, at this point.
Okay, I said something on if you have done, there was a packet trace I was doing then, and then I did it to some extent to show us something about how to be able to set up a wireless router. So I was like, this is the same thing on configuring DSCP. Configuring DSCP, you don't really configure DSCP, you just kind of choose DSCP as your kind of way of receiving IP addressing. So it's invariably creating a LAN. So when you set up a local network, then you configure a DSCP router to assign IPv4 address dynamically, then verify your network connectivity. That's test with client devices. Are you with me? So there is a packet tracer activity for it. That's what I'm invariably saying. So I can quickly show us on a simulated packet tracer what it looks like. Can we move on with that if that's what you are confused? I have the one I want, those I want to do is an optional exercise, even though I've done it on my system here. So we can be able to do something on that regard. So let me open up my packet tracer and show you like what it is. So I'm still with you guys. I don't want to show you like what it means when I say connecting DSC, even though I've done it here. What is it called? Present entire screen, please. I want to present my entire. Okay. 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 All right. So you guys can see my screen, right? Sorry. Okay, so you can see my screen. Can I get a thumbs up if that's so? Can I get a thumbs up? All right, thank you. So look how I'm saying. So invariably, we want to get a router. Just look at it. We want to get a router, but we want a wireless router. So where do we get a wireless router? So, let's get a wireless router. Let's get a wireless router. All right. This is a home router. This is a home router. All right, so let's get a device. Let's just assume this is a simulation, as I said. So I'm trying to show you what it means. And don't even have the like we'll get easy. Is there any other device that we want? Okay. Okay. So once this is having problem, I don't know. Difficult responding. All right. You can see this. You can see this. So in the router configuration, we already have enabled disable. So we want the DHCP server to be functional. So we'll leave these settings this way. So these are the devices that we want them to connect to this. So these are laptops. So what we'll do is we'll enter into the laptop and the laptop is already on. Hello, can you hear me? Sorry, I don't even know what network is today. All right. As I said, let me just quickly show you all just what I'm saying. So, as I'm saying, this one has already connected to our wireless device. So this one that is a P. We do IP configuration, and then choose DS. All right. I don't know if there's any concerns. You can express it, please. I think my system is having a little bit of issues. I don't know how to connect. So, is there any concern? Is there anything so far? So good. Stephanie, who is talking, please? Let's address any concern.
Yes, I lost you when you're trying to explain that packet tracer. I don't know if you can come back to it. I don't know if it's possible. Besides that, there's
I'm just,
nothing else.
I just trying to kind of, okay. Oh,
Hello, sir. That exercise too, I can't hear you when you were explaining it. The packet tracer.
As I said, this is how I want to. As I said,
We keep losing you, sir.
yeah, I know. So I want to okay. Let me delete all this and start afresh. I said, if you are still with me, I said, there is this exercise file I want to send you step-by-step instruction trying to show you a simulation of how an actual way of receiving a DSCP configuration looks like. That means receiving an IP address through DSCP. And I said before that, let me just show you a little bit of what the exercise is trying to lay emphasis on. And I try to bring out what we call, I try to bring out the router, which is this, and I then try to bring out Hello? Hello? Can you all hear me now? Yeah, I know it's almost time for classes. I'm already done with the
Yes,
classes.
sir. I hear you now.
I just needed to show the people that said they were not seeing what I was doing on the packet tracer. But invariably, what I did on the packet tracer was what I did when I started the class on trying to show you how to obtain IP address automatically with the DSCP from any device you are trying to connect with. That was what I was trying to do on the packet tracer. And I was saying something, I'm going to send you a file that have a step-by-step instructions on how to be able to also do that on your own. For those who want to, it's not a must do that. I've showed you how to on the live session here on classes. So for those who want to try it out on their own, you can also do the one that I did, whereby I entered my network settings, clicked on properties, click on TCP IP, then wanted to obtain the IP address. So at times, that is what it requires for us, either to obtain IP address automatically or to obtain IP address um, through by configuring statically or getting it through DSCP. So those are the two these things. On the packet tracer, you will get a step-by-step instruction. I just wanted to show you just more of connecting and then going to click on IP configuration, then going to click on receive IP configuration automatically. That's just what I was trying to show. But I don't know, my system has been really acting up. So aside from that, is there any other thing, please? Any other concerns? Hello, any other concerns? No concerns, that's none. Then I think we should prepare for our next class. We'll be talking about the remaining layers of the TCP/IP, which is the transport and the application layer. Then I think one other things we'll be doing next week is talking about operating system, which will be Linux operating systems. And that from there, the other person will take you on the network analysis practicals. That's lab. You'll be doing labs, a lot of labs within the course of the remaining week. I think that's the whole thing. I'm trying to establish the foundation so that when you see IP addressing, you will recognize it. When they say DHCP, you will know DHCP, what it entails. When they say, when we get to operating systems like Linux, you can be able to know how to use it. So with that, I think we'll be continuing our next section on Thursday. See you all. Thank you and God bless you. And I appreciate you all for understanding when networks is bad, when things are not really going as supposed. Thank you for remaining committed on this course. God bless you all. See you in your next class.
Thank you, sir.
Thank you, sir. Bye.